Hello and thanks very much for joining. Today I'm going to show you how you can access multiple NetCDF files in one go. So I'm going to show you how you can loop through different files using for loops. I'm going to show you how you can access data from different variables based on the variable names, and information stored as metadata as global attributes based on the global attributes names. Now, in some cases, you'll have variables that you know exist in some files, but that variable might not exist in every file you want to access. So I'm going to show you how you can use error handling to make sure you can access the data from the files that contain the data you're looking for, while skipping through or passing the files that don't include that data. And finally, I'm going to show you how you can access data based on the standard names, so the CF standard names. Now, this is from the climate and forecast conventions, and this is a standardized way of referring to data of a certain type. So it's a variable attribute that you can assign. And so in theory, let's say I have data for the seawater temperature. I can create a file and assign this seawater temperature standard name, and anyone else who also creates a file can also use this same seawater temperature standard name. This means that for the data user, if you are pulling data that I have created and this other person have created, you should be able to access the data in exactly the same way, because this standard name is a standardized way of referring to the data. So by accessing data based upon this standard name attribute, which is standardized, it's possible to access data from different files created by different people within the same script. Okay, let's dive in and I'll show you how to do all of this. Okay, so firstly let's load the libraries that we're going to use today. So we can do that with library and our NetCDF. And this is what we're going to use to work with the NetCDF files. And then we're going to load a second library called tidyverse. And what tidyverse does is allow us to work with data frames in a more tidy way. So what we're going to try and do today is load the data from a number of different files and dump them all into a single data frame. I found that people often prefer to have their data in a format that they're more familiar with, and data frames is a good example of that. The next thing we need to do is have a look at the files that we want to be working with today. So I've downloaded them all and listed them here. This is a long list of files, as you can see. I'm going to put a link down into the description to where you can access these files. But in brief, each of these files is a single depth profile of chlorophyll A data at a single time and location. So the first thing I need to do is get the file path. I'm going to copy this from here. And I'm going to store that file path as a variable, which is a folder which contains all of my NetCDF files. The next thing we want to do is make a list of all the files within that folder. So we can do that with list.files and write in folder here, which is our file path. If we print this, so this has given us a list of the different file names, but what we want is a list of the full file paths. So what we can do is write full.names equals true and run this again. And now when we have a look at this variable, we can see that we have the full file path. Then we want to loop through this files list and access each of these file paths and each of these NetCDF files in turn. So we can do that with a for loop. For, and then in brackets, file in files. So this is saying create a variable called file for each element in the files list. And then we can do these curly brackets. And as an example of how this works, we can just write here print file. And if I run this, we can see down in the terminal, each of these different files is accessed in turn. But we don't want to just print each file, we want to do something a bit more than this. So we can open each of these files with nc open.nc and file. And then we can print the contents of each file, print.nc, and the nc object here. And if we run this loop again, we can have a look at the contents of each of these files. So I'll provide you with an overview of what we're looking for within each file here. So within this particular file, we have a single dimension that has 2 points. Now I created all of these files myself, so I know that each of these files also has a single dimension depth, but some of the different files will have more points of depth. We then have a number of different variables. We have a depth variable, which is our coordinate variable with a dimension of depth, and some variable attributes for that. And then we have a number of data variables. So for example, chlorophyll A total with a dimension of depth, and again a number of variable attributes for this one. Then if we scroll down, we can get to the global attributes. So these are the metadata that describe the file as a whole. And we should have a consistent set of metadata within each file. So in this case, let's say I want to access geospatial lat min, geospatial lat max. And we know this is the same for each of these files because this is a depth profile at the same location. The longitude, geospatial lon min, time coverage start. And perhaps we also want to access the cruise number and the station name. So I'm going to show you how you can pull each of these attributes from the data file. And then we're also going to pull from the data file the depth variable and this chlorophyll A total variable. So we're going to pull all of these attributes and all of these variables together into a single data frame. Let's try that. So the first thing we're actually going to do is I'm going to go up here before this loop and we're going to initialize this data frame. So we'll call it df equals data.frame. If I run this, we have an empty data frame with 0 columns and 0 rows. So what we want to do is define what column headers we want. So that again is going to be a combination of attributes and variables. So let's create some vectors. We're going to create a variables vector. And we're going to make that equal to depth and also chlorophyll A total. And we need to make sure that this is the exact spelling of the variable name in our file. Because in this case, we're going to pull on the data using these variable names. And we're going to create a global attributes vector. And let's say in this case we're interested in the geospatial lat min, geospatial lon min. Let me move this onto multiple rows and put the C here. We also want the time coverage start and time coverage end. And finally, we're going to want the station name and the cruise name. Then finally, we're going to create a third list that we're going to call headers for our column headers. And this is going to be a combination of the variables and the global attributes. In fact, I will do the global attributes first because we want these to be our first headers and the variables to go second. So our global attributes are going to be constant for every row from the same file within our data frame. And our variable values are going to be different for every row in the data frame. Now we're going to initialize this data frame a little bit differently. We can write matrix here, and we can use this to define how many columns and rows we're going to use. So for example, if we wrote ncol equals 1 and nrow equals 2 or 3, and run this, and we have a look at our data frame object, we'll have an empty data frame with some NAs for 3 rows and a single column. Now actually we're going to initialize this with 0 rows, and the number of columns is going to be equal to the length of our headers vector. So if we have a look at that now, So you can see we have 0 rows and a separate column for each of our header names. We haven't assigned our header names yet. We can go and do that now. We can do that by writing call names for our data frame object and equal that to headers here. So now if we look at our data frame, we can see that each of the column headers is one of the elements in our headers vector. Okay, so let's return to our for loop here. We can get rid of this print. And what we're going to do now is that each time we run through the for loop, so for each iteration or for each file, we're going to create a new data frame and we're going to append the contents of that file to that data frame. And then after that, we'll append that new data frame to this old data frame and combine them all together. First thing I want to do is load in the depths for each of these files. So we can do that with var.get.nc. nc is our object here. The variable name is depth. And in the next row, we're going to look at the number of depths in each file. So we can do that with length depths. And if we look in this terminal here, we can see this is equal, in this case, to 2. So why did we do that? Well, now we know the dimensions of the new data frame that we're going to create. We know it's going to have the same column headers, and it's also going to have 2 rows in this case. So we can copy and paste this. Of course, we'll give it a new name. We'll call this new df, and we change this to num depths. So the number of rows in this data frame will be dictated by the number of depths in the file. So let's go ahead and write the column names again. We can do that with call names, this time new df, and make that equal to headers. Right, the next thing we want to do is access some of the attributes. So let's say we're interested in looking at the latitude attribute. We can have a look at that as at.get.nc. nc is our object. Because it's a global attribute, we write nc global. And the attribute we're interested in this time is geospatial lat min. If I run this, we have a look at this latitude object. See that I made a spelling mistake here. Let's write this again. And latitude. But we don't want to just access a single attribute here. We want to access each of these global attributes that we wrote here. So we can do another for loop. So let's create a bit more space and scroll down. I can write for global attributes in global attributes, and then again with the curly brackets, and within this we're going to access this. And instead of writing our attribute name here, we can replace this now with global attribute. So each time we go through another element in this vector, we're going to access a different attribute. We can delete this line. And instead of writing this out, we can just print this now and have a look at how this looks. So if I run these 3 lines, we can see that we've written out a different attribute each time. But we don't want to just write each attribute out a single time. We want to write this for every single row in our data frame. And we can do that very easily. So we'll remove this print around here. And what we can do is write new df, and the column name we want to access within the square brackets is actually the same name here, global attribute. So let's try that. If I run this, if we have a look in the console, we can see that we've written these values for every single row. We can use the same logic now for our variables. So for variable in variables, again our curved brackets, and we can write new df variable is equal to var.get.nc, NC is our NetCDF object again, and our variable name is variable. But in this case, it's not just going to be a single value, it's going to be different values. So let's run that. And we'll have a look at our data frame again in the console. And here we are, we can see our different values for chlorophyll A each time here. The eagle-eyed amongst you might notice this extra column here entitled NA. We can ignore this is just due to an error I wrote earlier in the script. That should be corrected when we run everything next time. So great, we're creating a new data frame every time we run this loop, and we're going to append those now to the original data frame. So we can do that by writing merge, and we merge df with new df, and we're going to write all equals true. And to make sure we're writing this out every time, so we're going to iteratively update this original data frame. We're going to write this out here. So merge the old data frame with a new data frame and overwrite the old one. Loop again and continue. So we can run this whole loop now. We can just go to this first loop and write this here. And as you can see, we get some errors in this case. Now, why is this? Well, this is because some of the variables that we're trying to access aren't present in every single one of the files. So what we need to do is think of a way to write the variables if they exist in the file, and to pass or ignore that file if they don't exist. So this brings us on to error handling. And to do this, we're going to go right to the top of our script, because in R we do error handling by writing a new function. So let's make some space up here. Now, in case you haven't ever written a function before, I'm going to give you a really simple example. Let's define a function called add1, and we're going to create a function here, and within these brackets I'm going to write number, and then we're going to have some curly brackets. I'm going to write return number plus 1. So what am I doing here? I'm saying let's define a function called add1, and each time we run that function we're going to provide a number, and we're going to return that number plus 1. So I'll run this to initialize a function, and then if I write add1 and then in brackets I put, for example, 4, we see in our terminal we have the number 5. Okay, so that was a quick crash course in writing functions, but we're going to have to write something a little bit more complicated in this case. So what we want is a function that is going to extract a variable from NetCDF. So this is going to be the name of our function. The user of the function is going to provide the NetCDF object and also the variable name. And so the neat thing is that we can define what happens within this function if it is to fail. So let's clean this up a little bit. And we can do that with try catch. And we can nest our function within here. And we're going to open some curly brackets within here. And within this first set of curly brackets, we're going to define what we want this function to do if it runs successfully. So we're going to write result equals var.get.nc nc variable, and then it's going to return that variable result. So if we run this variable, it's going to return the result of this line. But then we can also say what should happen if we have an error. So we can write error equals function cond, then we're going to write some more curly brackets, and we're going to output a message. And we can write here is the original error message, and we can write message cond. So what's this going to do? It's going to attempt to run this function here. If it can't run this function, if there is an error, it's going to save that error message to a variable called cond. And in the console, it's going to print out, here is the original message, and it's going to print out cond, the original error message. What it's not going to do is fail. It's going to continue with the rest of the script. Now we're going to need a separate function as well for our attributes. So I'm going to copy this, and we can write extract global attribute from NetCDF. We're going to call our NetCDF object and also our global attribute name, or the name of the attribute we want to extract. And this time the function is going to be at.get.nc and global attribute. And we also need to write the name of our variable, which, because it's a global attribute, we write nc global. So try and output this global attribute, and if you can't, write this error message. And if we want, we can make this error message a bit more useful. We might want to let the user know exactly what attribute is causing the problem. If we want to do that, we can just write here global attribute, and this will just print out the name of the global attribute. And we can also write something onto that as well. So if we write paste, what paste does is concatenate two different strings or text type variables. So paste global attribute to this, where I'm going to write attribute not found. So if my global attribute is latitude, it's going to write latitude attribute not found. And we can write something more useful for the variables as well. So I change this here to variable. Okay, so we've written our two variables now. What we want to do now is use these within our script further down. So here, instead of this at.get.nc, we can replace all of this with extract global attribute from a NetCDF file, and we can write here nc global attribute, and we can replace this one with extract variable from NetCDF, and we can write nc and variable. So the last thing to do is run all of this. We'll get a couple of warning messages here. These are not errors, everything seems to have run okay. If we're not sure, we can have a look at our data frame in the console, and we can see everything has been written down here. Actually, in this case, only 519 rows have been written out. One thing I quite like to do is output this to Excel or something, or a CSV file, to have a proper look at it. So we can do that. We can use the library write Excel. So if we write xlsx, data frame, and some file path and run this, we can go and find that file, and we open it up, we can see all of our data have been printed here. Returning to the NetCDF file now, that method's all well and good if we know this variable name. However, this variable name is defined by the user and is not standardized. So if we're going to extract data from different files created from different people, we can't use this method in quite such an automated way. What we want to do is pull data based on the standard name. And this is a standardized term that's been assigned to each variable of this certain type. If I scroll down into the global attributes, we can see that the conventions used within this file are from the climate and forecast conventions, CF version 1.9. So if I open up a web browser, and I'm going to use Firefox, and then within that I'm using the search engine Ecosia, because they plant trees with all the revenue that they make. So I can write in here CF standard names, and I go to here, and we have a standard name table here. So if I quickly return to our file, and find the variable that we're looking for, we have this standard name here, mass concentration of chlorophyll A in seawater. I can copy and paste this and search for this here. We have the variable name and we have a description as well. And so the data creator should have read through this description and chosen a suitable standard name for their variable based on these descriptions. And you, as a data user, can also come to this page, read this description, and so you as a data user should have the same understanding of what is within that variable as the data creator. It removes any ambiguity. I talk about the CF conventions in another video, Introduction to NetCDF files, and I'll put a link to that down in the description. So back to the file, let's say we want to pull all the variables that have this standard name as a variable attribute, and also the depth standard name. So how can we do that? Well, the first thing I'm going to do is I'm going to save this script and create a new script so we have a new clean slate to work with. We can copy and paste some of the useful information from this first script. In fact, we'll copy and paste it all into here and we'll remove what we don't need. So what we need to remove is our dependency on these variable names. So we can remove this function here, they're extracting the variables. We're going to keep this function for extracting the global attributes. Now actually these global attributes, or most of these attributes that we have written here, are taken from the ACDD conventions, or the attribute conventions for data discovery. If you write ACDD conventions in your browser, you will find this here. So this is a list of highly recommended and required terms that you can include in a NetCDF file. Again, I don't want to go into that in too much detail here. We want to remove this variables vector, and instead we want to write a standard names vector. So these are the standard names that we want to be searching for. So the first one is depth, and the second one is this mass concentration of chlorophyll A in seawater that we had a look at earlier. Remove this space, and the headers of this data frame, instead of having variables here, we're going to have standard names. We're still going to loop for each file in turn, but in this case we don't necessarily know what our depth variable is going to be called, so we can comment this out here. We can also comment out this line. We can still loop for our global attributes, but we can comment out this loop for the variables for now. Okay, so we're left in this position now where we don't know how many variables are in each file, we don't know what the variables are called, but we're hoping that in some of these files, some of the variables have a variable attribute called standard name. So what we need to do is somehow find a way of searching through our file and searching through the different variables for this attribute. So we can print out this NetCDF object that we still have in our console. Now what we've previously been doing is accessing the variables based on their variable name. What we can also do is access these variables based on an index number. So we can write var.get.nc, nc is our object, and we can write 0, and we can see the values for the first variable. I could do this again with 1, with 2, etc. So why is that information useful for us? Well, that allows us to loop through the variables regardless of their variable names. So we can find how many variables we have in each file by writing file.inc, you can think of it like inquire, nc, and nc, and then what we're interested in finding out in this case is the number of variables, so we can write nvars. We're returned with this. In this case, if we want this to be returned as a single number, we can write as.integer to return this as an integer value. So I'm going to copy this from our terminal. If we go back to our script, and at the beginning of this for loop here, so we've opened the file, so what we're going to write here is nvars is equal to this. And below this we can write for variable, or variable index, var index, var idx, in nvars, But actually this is just a single number. What we want is to go between 0 and this number here. But even more than this, we want to go between 0 and this take 1. So for example, if we have 6 variables, this n vars is going to be 6, but because we start with 0, they're going to be numbered 0 to 5. So if we had 6 variables and we were to loop through this var IDEX would be assigned for numbers 0, 1, 2, 3, 4, 5, for example. So we want to do something within that. So if we wanted to load our data now, we could do that with var.get.nc, nc for our objects, and var index for the index. But we don't want to do that in this case. What we want to do for each variable is find out how many attributes we have. So we can write this n atches, and in this case we can make this equal to var.inc.nc. nc is our object, and the variable we want to inquire about is the index that we have just written. And then the attribute within this, what we're going to write out, is n atts. I've confusingly assigned this an r here, so I'll remove that. And again, we want to say this is an integer, so we can do that. Now, just like variables can be loaded based on an index, so can be attributes. So we can write for at index in 0 n atts minus 1, the same logic as above, and go for another loop here. So within each of the loops where we're looping for each variable, we're looping for through each attribute within that variable. Now, we're not interested in most of the variable attributes, we're only interested in the standard name attributes. So let's write out the attribute name here. So we can do that again, at.inc.nc. nc is our object, var index is the variable we're interested in, and at index is the attribute index we're interested in. And the attribute of that we want to write out is name. I hope this is still clear. If not, you can try and listen through this again. So then we only want to do something if this attribute name is standard name. So we can write if, then in brackets, at name, doubles equals sign, to standard name. So only if then we perform a certain action. Then we will write the standard name, we're just going to call this sname here for simplicity, as at.get.nc, nc, var index, at index, and then again only if this standard name is equal to depth, only then do we want to do something. So then we can take these lines that we wrote earlier. To get our depths, we can call this here. But instead of calling this depths variable based on this variable name, we want to call it based on its index, var index. So a quick loop through this, we're looping through each of the variables, looping through each of the variable attributes within that variable, and then we're only doing something if the variable has a standard name and if that standard name is depth. If we find that standard name depth, we're assigning that number of depths. We might also want to assign a value for num depths here as 0. And the reason we might want to do this is that if there isn't a depth standard name within the file, we have a fallback here, so this variable is still going to exist. And if that doesn't exist, if there isn't a depth in the file, we probably want to skip and not process this. So back down to the script here. We can remove these lines that we commented out now. We still want to create the data frame in the same way. We can go ahead and assign the attributes. But now we've got to do something again for the variables. So we're going to use the exact same logic as we used here, to scan through the other variables for our other standard names that we want to search for. So let's start on here. But this time we want to scan for standard names where the standard name is in the vector that we created earlier. So here. This time we just have 2 standard names, so we could just take this. However, it might be that we have more standard names than this and we might want to do a little bit more. I'm seeing here actually that we didn't actually do this. Good job if you noticed that earlier. So what we can write down here then is instead of sname equals depth, we can say if sname in standard names. So instead of doing this, what we want to do is still extract the variable based on the index, but instead of writing it to a depth variable, we want to write it into our data frame. So we can do that here. If we remove this line again, and we'll recall the last time we did this loop, we actually didn't write out any of the values to the data frame, we just used a number of depths to assign the number of rows in our data frame. So what we're doing this time is looping through each of the variables. If one of those variables includes a standard name, which is in our standard name vector, then we can write out those variables to our data frame. So it will first be depth, and it will then be the mass concentration of chlorophyll A in seawater. I'm sure some of you are shouting out about this operator. This is a hangover from Python, but in R you need to have this in between these percent signs. So that should be that, and if I delete this bit here, we don't need anymore. And if I change this file name to standard names, and I run everything, well, apparently there's some error, object variable not found, and that's because I've written variable here, and we don't have a variable object, so we should write here sname instead. If I write this again, if we go and have a look at our data now, we should see our data here. The only difference should be from last time is that these column headers should be the standard names rather than the variable names. So I hope you found this useful. You might need to change a few things depending on the configurations of your NetCDF files, but if you do have any questions, please drop a comment down below. Thanks very much for listening.